Welcome back to this video tutorial. We can discuss about the basic property of cache memory in this video. So from this diagram it is clear that the cache memory is present in between the processor and the main memory. Okay, and also the size of this cache memory is smaller than that of the primary memory. Okay, and this cache memory holds a set of data which is a copy of the data available in this primary memory, and the presence of this cache memory increases the memory access operation speed. Okay, now we can consider this working of this cache memory in detail. So cache memory, the speed of the main memory is very low in comparison with the speed of modern processors. Modern processors are very fast in their operation, but the memory access operation takes more time. Okay, so the processor time get wasted by waiting for the memory access operation to complete. Okay, the processor can start the execution only after getting instructions and data from the memory. So it always requires memory access operation, right? But that memory access operation takes more time. That will reduce the speed of our modern processors. Okay, the cache memory is an architectural arrangement which makes the main memory appear to the processor to be faster than it really is. So the presence of cache memory in between this primary memory and the CPU, it will help to reduce the time of memory access time. Okay, that means the presence of this cache memory actually increase the speed of memory access operation. Okay, so the working principle of our cache memory is locality of reference. That means the cache memory is implemented based on the property that is called the locality of reference. The effectiveness of the cache mechanism is based on a property of computer program called this locality of reference. This locality of reference is the working principle of our cache memory. Okay, so this locality of reference can be considered as temporal locality of reference and spatial locality of reference. Okay, so these two are together called as locality of reference, temporal and spatial reference. Okay, if the active segment of a program can be placed in the fast cache memory, then the total execution time can be reduced significantly. Okay, that means the active segment of a program code that is currently being executed, if it is present in the cache memory, then we can increase the speed of memory access operation. What do I mean by this active segment? The active segment of a program is defined based on the temporal and spatial locality. Okay. Temporal locality means the recently executed instruction is likely to be executed again very soon. Okay, so this is one assumption that, or this is experienced while executing a program. It is experienced many times that a recently executed instruction is going to be executed again and again very soon. Okay, so that property is known as temporal. If one instruction is executing now, then the chance of executing that instruction in a recent time instant is higher. Chance to execute that instruction in a recent time instant is higher. That is called this temporal property. And what about the spatial property? Instruction in close proximity to a recently executed instruction are likely to be executed soon. That means this indicates that the processor are usually, or majority of the time, processor is executing the instruction in a sequential manner. That is why while executing a particular instruction, the chance to execute the sequentially next instruction is very high. Okay, that property is represented using the spatial reference. So based on this temporal and spatial references, we can understand, or we can define a particular active segment of a program code. If that particular active segment is present in our fast cache memory, then we can increase the speed of memory access operation. How can we identify an active segment of a program code? Based on the temporal and spatial references. What is this temporal reference? Temporal reference means if an instruction is executed now, the chance to execute that instruction in a recent time interval or a recent time instant is very high. Chance to execute that instruction again in a recent time instant is very high. Okay, then about the spatial reference. What is this? That means the processor, the chance to execute an instruction which is sequentially next to the currently executing instruction is very high. Okay, that means processor, in majority of the time processor supports sequential instruction execution, so that the chance to execute the next sequentially present instruction, the processor is executing an instruction now and the chance to execute the next sequential instruction is very high. So based on this property, we can define an active segment of the program code, and if it is possible to place that active segment in the cache memory, we can increase the speed of our memory access operation, which will help to increase the performance of our processor. Okay. So operation of a cache memory. Operation of a cache takes advantage of the property of this locality of references. This locality of reference includes spatial and temporal reference. The temporal aspects of the locality of reference suggest that whenever an instruction or data is first needed, this item should be brought into the cache so that for subsequent references, item can be fetched from the cache directly. Okay, so in order to satisfy this reference, locality of reference, that includes spatial as well as temporal references. Okay, in order to satisfy the temporal aspect of locality, what we want to do, whenever the processor requires a memory word, that may be an instruction or a data. Whenever the processor requesting such a memory word for the first time, we must place that data or that particular memory word we fetch from the main memory and place it into the cache memory, so that while requesting the data or the memory word again in a recent time instant, the data will directly available from the cache memory, right? So we can satisfy this temporal aspect of locality. That means while requesting a memory word for the first time, we can place data, we can take the data from the primary memory and place it into the cache memory, so that while requesting the data for the next time, it will directly available from the cache memory. Okay, the spatial aspects suggest that instead of fetching just one item from the main memory to the cache, it is useful to fetch several items that reside at adjacent addresses as well. So in order to satisfy the next locality of reference, that is for satisfying the spatial aspect of locality of reference, what we want to do, instead of fetching and placing a single memory word to the cache memory, we can fetch a block of memory words that are adjacent to the currently requesting memory word. We can fetch a block of memory words that are adjacent to the currently requesting memory word, okay, and place it into cache memory, so that while requesting or while placing a new request for a new memory word which is adjacent to the currently executing instruction, that instruction will directly available from our cache memory. Okay, so these are the principles of cache memory working. Okay, so here we have one term, cache block or cache line. Okay, cache block means in order to satisfy this spatial aspect of locality of reference, we need to fetch a block of memory words that include the currently requesting memory word also. Okay, so fetch a block of memory word and place that block of memory word into our cache memory. Such a block is called cache block or a cache line. Okay, a set of continuous address location of memory words of definite size that is fetched from the memory at a time. Okay, so we need to fetch a block of memory words and the size of that block should be of a definite size. Okay, we can't specify block of different size. We have to consider a memory block of a definite size, and that block must contain the memory word that is currently requesting by the processor. Okay, we need to fetch that block from the memory and place it into cache memory. Okay, so while placing the second instruction or a second request by the processor to fetch a new memory word from the new memory word, then that memory word is directly available in the cache memory. It will increase the speed of memory access operation. Okay, so when a read request is received from the processor, the content of a block of memory words containing the location referenced are transferred into the cache one word at a time. Okay, subsequently, when a program references any of the location in this block, the desired contents are read directly from the cache. So this is the working principle of our cache memory. One is temporal locality and the other is spatial locality. Okay, from the diagram it is clear that the capacity of the cache memory is less compared to that of the main memory. Okay, as the total number of block in the cache memory is less compared to the total number of block in the main memory. A cache memory can't hold all the blocks present in the main memory because the size of the cache is always less than that of the main memory. Okay, suppose consider a situation like the cache memory is completely filled with certain blocks from the main memory and the processor is requesting for a new memory word. Okay, in that case we need to transfer a new block of memory words from our primary memory, which is not currently available in our cache memory, but the cache memory is almost full now. We haven't enough space in our cache memory to hold the new block from the cache memory. What we want to do now, we need to replace certain blocks available in our cache memory in order to make enough space in the cache memory so that we can hold a new block from the cache memory in which that particular memory word is available, which is currently requesting by the processor. Okay, so this is one case, that is about this replacement algorithm. If the cache memory is not containing enough space for holding a new block from the primary memory, in that case we need to remove certain block from the cache memory and make enough space there and place new block in the cache memory. So in order to decide which block we want to replace from the cache memory, so here we have certain replacement algorithm that decide which block from the cache memory we need to replace now. Okay, and also here we have certain cache mapping function. These cache mapping functions are actually used for mapping certain blocks from the primary memory into certain locations of our cache memory. Okay, in order to define certain correspondence between primary memory block with the cache memory block, we have certain mapping function. Okay, using this mapping function, we can map certain primary memory block to a particular location in the cache memory. Okay, so we can study detail about this mapping function as well as this replacement algorithm in our coming videos. Okay, and now we have to understand certain operations that occurs in case of cache memory accessing, that is cache hit and cache miss. Cache hit means read hit or a write hit. That means whenever a processor plays a read request or a write request for a particular memory word, and if the requested word is available in our cache memory itself, that indicate a cache hit. Okay, if the requested word is not present in the cache, then it indicate a cache miss. Okay, in usual case, this is a property of our cache memory, that is the cache memory is transparent to the processor. That means processor is not aware about the presence of this smaller fast cache memory in between the primary memory and the processor. Okay, so while placing a request for a particular memory word, processor always aim to get data from the primary memory because this cache memory is transparent to the processor. Okay, so processor can't identify whether the data is coming from the cache memory or from the primary memory. Always it targeted to the primary memory, that is it need data from the primary memory, and also always specify the address of our primary location. Primary memory location. Okay. So while placing a read request or a write request, it simply issues a read or write request using the address that refer to the location in our primary memory, because the processor is not aware about the presence of cache memory in between the processor and our primary memory. Okay. If the requested word currently exists in the cache, the read or write operation is performed on the appropriate cache location. We don't want to consider the presence of that word in the main memory. If the requested word is present in the cache, then we can perform that operation on the data on the copy which is available in the cache location. We don't want to make any change over the main memory content. We can work with the copy available in the cache memory. Okay, so this is the case of cache hit. If the processor is placing read request or a write request, then the data is available in the in the cache memory. Then the data, we can pass the data from the cache memory, or we can write or we can modify the data which is present in the cache memory. We don't want to consider the copy available in our main memory. Okay, so consider first about the write hit. Write hit means the processor is placing a request for writing over a memory word. Okay, and the requested memory word is now available in our cache memory. That is the case of write hit. Processor want to perform a memory write operation, and the requested memory word is available in our cache memory. So this is the case of write hit. For a write hit, the system can proceed in two different ways. That means whenever a write hit occurs, we can implement that write hit operation in two different ways. One is write through method. What is this write through method? The cache location and the main memory location are updated simultaneously. In case of this write through method of writing operation, memory write operation, both the cache location and the main memory location are updated simultaneously. Okay, that means write hit means the processor is requesting to perform a write operation over a particular memory word. And if that particular memory word is available in our cache memory, that causes a write hit situation. Okay, so in order to manage this write hit operation, we can perform that write hit operation, or we can complete that write hit operation using this write through principle. What is this write through principle? We can write, or the processor can update the memory word which is present in the cache location, and also change the memory content corresponding memory word which is available in the primary memory. Whenever a write operation want to perform, update both the cache memory copy as well as the main memory copy. That is the principle of this write through method. Okay, advantage, this is a simpler method. Directly update both the copies of the same data. Processor want to update one memory word, and the copy of that memory word is available in our cache memory, and by following this write through principle, processor update both the cache memory copy as well as the prime memory copy. This is a simpler protocol of write hit operation. And the disadvantage is the result, this particular write through operation results unnecessary write operation in the main memory. That means when a given cache word is updated several times continuously, then each time the processor want to update both in cache memory location and in primary memory location. Okay, so we have a assumption that is temporal locality. That is, while considering a particular, while accessing particular memory word, the chance to access that memory word again and again is very high. So here the processor want to perform a write operation. Okay, so if the condition occurs, that is, we are going to update that same memory word again and again, and in that situation, at each case we need to, or the processor need to update both in the cache copy and in the main memory copy, which will result unnecessary write operation in the main memory. So this is the disadvantage of this write through approach of write hit operation. Next method of writing is memory writing is the write back approach or copy back approach. What is this? Update only the cache location and mark it as an updated, mark it as updated by an associated flag bit called a dirty or a modified bit. That means here is the same situation, that is the write hit situation. Processor want to perform a write operation and the memory word on which the processor want to write is available in the cache memory. That is why the situation write hit. And here we want to complete this write operation with the help of this write back property. What is this write back property? Here the processor update only the cache memory copy. It does not simultaneously update the primary memory copy. Here it simply update the cache copy, and associated with that copy or that memory word, here it is a flag bit associated with each cache memory word, which is associated with a flag bit. So while updating the cache copy, this flag bit get updated in order to indicate that that particular memory word is updated. That particular cache copy is updated by the processor. Okay, so that particular flag bit associated with the memory word is known as dirty or modified bit. Okay, with the help of this flag bit, the processor can update the cache copy only and also change the flag bit value in order to indicate that particular block, that particular word is updated. And the main memory location of that particular word is updated later when the block containing this marked word is to be removed from the cache to make room for a new block. That means in this write back approach, the processor update only the cache copy of the memory word and change or mark its dirty bit as, or update this dirty bit in order to indicate that that particular memory word is updated. Okay, and whenever that changes get updated in primary memory, the changes get updated in primary memory only when a memory replacement, memory block replacement or a cache block replacement takes place. Okay, so after a later time instant, whenever that particular memory block in which that modified memory word is present, whenever that cache block is replaced with a new value, the replaced block is placed back into its primary memory location. In that case or in that time instant, the value get modified in the primary memory also. Okay, so this write back protocol may also result in unnecessary write operation. How? When a cache block is written back to the memory, all the words of the block are returned back, even if only a single word has been modified during its residence in the cache. This write back protocol also shows certain disadvantages or shows this unnecessary write operation. How it happens? That means here, while performing a cache replacement or a cache block replacement, we need to transfer the entire block of memory that contains the modified memory word. Okay, so while replacing a block to the primary memory, we need to modify or rewrite each and every memory word present in that cache block. even though only a single memory word is get updated while this cache hit operation, but here we need to rewrite each and every memory word present in that block. So it will also increase number of write operation and cause unnecessary write operation. Okay, so in case of write hit operation, we can implement the write hit using write back approach and write through approach. The basic working is write through means whenever a cache copy get updated, simultaneously the primary memory copy also get updated. And in case of write back approach, only the cache copy is updated first. And associated with each block, each memory word assigned with a flag bit, and the flag bit is updated in order to indicate that a particular memory word is updated. Okay, and the corresponding primary memory block or the primary memory word get updated only when that memory cache memory block is replaced from the cache memory. Okay, so next is about a read miss. What is this read miss? Read miss is a case of cache miss. From this it is clear that processor is now requesting for a memory word. In order to read certain data or a instruction from the memory, processor is now placing a read request. But the requested memory word is not present in our cache memory. So this is the case of read miss. Okay, when the addressed word in the read operation is not in the cache, a read miss occurs. The block of word that contains the requested word is copied from the main memory into the cache first. Okay, as just like our previous case of write, whenever a read miss occurs, the processor want to we want to copy a block of memory word that contains the requested memory word copied into cache memory first and pass the requested memory word to the processor. This is the working in case of read miss. First we want to copy a block of memory word that includes the requested memory word. First copied into cache memory and pass the requested memory word to the processor. Okay, and read miss operation can be performed, or we can call it as the load through or an early restart. During a read miss, the word may be sent to the processor as soon as it is read from the main memory. Okay, so we can read a block of data from the primary memory that contains the requested memory word, and as and when that is copied into cache memory, which is directly passed to the processor. This approach is called load through or a early restart approach. Okay, so using this, it can reduce the waiting time of our processor, but for implementing this, we need complex circuit. Okay, load through approach means copied into cache memory, and the copy from the copy of memory block, the requested word is passed to the processor. Okay, and about this write miss, what is this write miss? The situation is processor is requesting for a memory word in order to perform a write operation. Okay, and the requested memory word is not present in the cache memory. That is this write miss situation. Okay, during this write operation, if the addressed word is not in the cache, this causes a write miss operation. So this write miss, in case of write through protocol, the information is written directly into the memory. If the requested memory word is not present in the cache, in write through protocol, we can directly update the copy which is present in the main memory. We don't want to take the copy into cache memory. We can simply update the main memory copy. We don't want to take any copy. We don't want to make any copy or take any copy from the main memory to cache memory. Directly update into main memory. Okay, this is the case of write through approach. And in case of write back approach, first copy a block of main memory content that contains the requested memory word. First copied into cache memory and make certain updation over the requested data and Later it is replaced back into main memory. So this is the case of write back approach. Okay, so these are the operation taking place in a cache memory operation: cache hit and cache miss operation. And cache hit contain read hit and write hit. Read operation means what? Read does not make any changes over the memory word. Okay, so read hit is a simple operation. Whenever the requested processor is placing a read request and the requested data is directly available from the cache memory, it does not does not make any change over the requested data, because this is a read operation. Okay, we can simply pass the requested data from the cache memory to the processor in a very limited time duration. Okay, so read hit is a simple with operation. It does not make any complication and updation. Okay, and in case of write hit, we can implement using this write through approach or write back approach. And in case of read miss, we can directly copy a block of data from the main memory to cache memory, then pass the requested memory word to the processor. Okay, and in case of write miss, we can directly update the main memory copy without copying that content into cache memory. That is called write through approach. And in case of write back approach, first take the copy to the cache memory, then make certain modification over the requested data, and later it plays back into the primary memory. Okay, so all these are the basic working principles of cache memory. So mainly concentrate on the locality of reference property, that is the working principle of our cache memory. And in locality of reference, we have the temporal locality and spatial locality. Okay, thank you.